Hey everybody, I'm Armand. Like Justin said, I work at InVision App Inc., makers of InVision, the prototyping software, and I think that's what we're pretty classically known for. But anymore, we have a huge digital whiteboarding product and collaboration space called InVision Freehand. That's what I've been doing for a lot of ideation stuff. It's pretty neat. So I think it's a really cool place to work. I'll drop a quick note that we are hiring all kinds of engineering positions, front end, back end, especially if anybody knows MongoDB, actually just let me know. I could definitely use some MongoDB advice. But yeah, I think it's a cool place to work. I like it a lot. So I'll make that announcement there. Yep, hiring, looking for people. And I am primarily a front-end engineer. I've started doing more back-end stuff lately. Work a lot in Go, Node.js, TypeScript on the front end. That's a big part of it. I've done a bunch of React for quite a long time. And as I guess people have probably guessed from the subject of this talk, I'm a big fan of a lot of different programming languages. I love the theory of programming languages. I like learning about different ones. I like to just look at features and comparative implementations and see how they work and what the thought process behind their implementations and designs are. I've always just really, really loved that stuff. So today I am going to talk about a personal project that I started, I think maybe September of 2020. It was a while ago and I just kind of did it almost by accident. It took over another project that I was working on at the time and just started kind of growing and becoming a little bit of an obsession on the side. It is a programming language that's based on another language that I'll talk about. I didn't invent most of the stuff here. It's just something I wanted to season to taste. And really is like a learning experience, something I wanted to try. I had built little tiny toy languages before. I wanted to try something more serious. And I'm just going to start by kind of going through some of that. I have a few slides prepared, which I guess I'll share. I bothered to make them. But
before you jump in,
yeah.
Before you jump in, for those who are new to the meeting in the last few minutes, if you have questions, feel free to you do the raise hand feature in Zoom. You can also drop them in the chat if you want to. And so we'll watch both of those things. And so feel free to do that. Anyway, sorry to interrupt you there. Go ahead, Armand.
How do you do the raise hand, Eric?
I didn't do it.
Oh.
Hey, Justin.
Justin did it.
How do you do that?
Yeah, down on the bottom, there's a reactions button. And that brings up a couple emojis and a raise hand button.
Okay, I see. Thank you. I just zoned it.
So this is why we keep people like Justin around, the young ones, because I'm old and I'm not good at emojis.
I'm hip with the Zooms.
You're hip with the Zoom, so we're glad you're here, Justin.
Thanks.
Yeah. Anyway, go ahead, Armand.
Awesome, sure thing. And yep, as mentioned, I'm fine if anybody wants to hop in with questions or, just to explore something else. A lot of this is going to be code demos, just looking through the stuff that I've built, talking about the decisions and, comparing with other languages and everything. So there's going to be a lot of that. Feel free to, raise hand, interject, and we can talk about anything. Okay, so let me get my presentation going here. I'll start sharing my screen. Okay. Great. I hope that be helpful if I start on the first slide. Awesome. All right. Can everybody see this? Okay. Yes.
Yeah,
awesome.
I can see it.
Okay, great. So this is a talk that I was, as of Monday, Justin came to me and said, hey, we've got an opening to be able to, well, I think it was our speaker dropped out and we got a space. Do you want to do a talk at InVision? I host these engineering practices meetups. We get together, we just talk about, how we build software, how we get better as engineers. And they tend to be kind of 30-minute tech talks. We've had a bunch of topics from Docker, using Docker for local development and like large container orchestration systems. We've had talks about, programming language choices, tricks in TypeScript, in team practices and communication tricks and collaboration stuff. So we've done a bunch of those like sort of shorter talks. And today I want to talk about an experience of building a programming language from scratch for fun. So first, hi, everybody. I did a little intro earlier, so this slide isn't necessary. And I just wanted to say, like, thanks for letting me come here. Thanks for letting me try this out. This talk is unrehearsed, very experimental. If it is cool and interesting and fun, I would maybe try it out again somewhere else. So thanks for letting me workshop this with you. I really appreciate it. I hope it's fun for everybody. There's a fun thing I came up with I'll get to in a minute. Actually, you know what? We're going to do it right now. I figured that there might be a lot of things that could go wrong during the course of this talk. So I had the foresight to come up with a little kind of disaster bingo here. I'm going to go ahead and send this link to everybody. This can generate you a random little bingo card if you'd like to play along. If not, that's totally fine. But I figured it might be fun to just see if every possible bad thing happens that could possibly happen, we can keep track of it here. And if anybody wins, I will come up with a fun, cool prize to give you. I don't know why I can't paste this in here. Is it too big?
Is copy paste error on the bingo card? Because I call it.
No, that would have been good. I guess maybe it is too long. Oh, shucks. I was really hoping this would work. It's probably because it's all in the URL here. Well, I'll be playing along privately. Too bad. I thought that would be fun. Justin, if you could think of a way that I could share a just big honking long link with people, let me know, and others can play along too.
You can send it to my Slack, and I can send it to the group Slack.
There you go.
Okay, yeah, I can do that. I got that on my other machine here. Let's see. No, I don't want to spend too much time on it. Oh, well, that would have been a fun idea.
Hey, demo doesn't work was an option on that.
Yeah, that's right. If you had that one is definitely going to be, I think, coming up. There are some hot ones on there. So I want to say that the point of this talk is really just to kind of go through the experiences I had and point out some stuff that I learned about primarily JavaScript. That's my language of choice. It's what I'm most familiar with. JavaScript and TypeScript, looking at decisions of programming language authors, why they do what they do, some weird bugs, issues, and things that I had come across that were really unexpected, and some of the joys of building a project like this. So I'll say that it's pretty much going to be driven by why I did this, by my story. I'm going to take it beat by beat and walk you through it. There's going to be a lot of demonstrations. Most of this, I'm hoping, is going to be looking at code, looking at repositories, trying things out. And this is a total shot in the dark. I hope it works. What it isn't is an expert opinion. I am an amateur that thinks parsers are cool. So take everything I say with a grain of salt. It's not a structured lesson. If you learn anything, it's by accident. And it's not an advertisement. This is not a project that I'm trying to sell. I don't have the source code published anywhere. Maybe in some nightmare universe that'll happen. But for now, this is really just going through bit by bit and trying to share the story. So I think the pertinent question is, why should anyone build a programming language? There's a lot of really good ones out there already. What is the purpose of it? Why would anyone choose to pursue this? My biggest reason is it's fun. It's really, really fun. Learning how to build your own programming language is the type of thing that I think unlocks something inside of your mind. It's a way to become just a drastically better engineer. It lets you explore and experiment. It gives you a reason. And I find I definitely need like some motivation, some reason to go out and look and try things. And this gives you a big one to explore and experiment, to try different languages, to look at why things are built how they are, to read and consume new information. It's just a fantastic excuse to do that. And it's a way to challenge yourself, like I said, to get way, way better at what you do. Building a programming language is going to really, really test the limits of your knowledge, and you're going to learn a ton doing it. And one of the cooler things for me was it dispels a lot of mystery. There's things that I didn't know or understand before trying this about how stuff worked or why it worked the way it does. And this shed a lot of light on the internals and mysterious things about just how computers work, how the software that I use every day works. And dispelling the mystery around that made it a lot more comprehensible and made me feel like, oh, okay, I can actually work with this. I can change it. I can do something with it. So that was an incredible aspect to it. And it's just immensely satisfying seeing this work, seeing something function that you built and with this scale and complexity. It's really, really cool. Even if it's just a dinky little like language, like a very simple Lisp-like language, it doesn't have a lot of stuff in it. It's really, really neat to see yourself doing it. And I wholeheartedly recommend it. So this brings me to why did I build a programming language? This started kind of with the advent of code. The advent of code, for anybody who doesn't know, is an annual event where there is a daily programming challenge, a puzzle essentially, for each of the 25 days of traditional Christmas. One challenge a day, they get progressively harder, and you get to solve them in whatever language you like. You get a little bit of puzzle input, a chunk of data, a file, some text, some numbers, and a problem to solve. These are really, really fun. If you've never done one, it starts today. It's the first day of the Advent of Code 2021. I recommend trying it out. It's another great way to learn and practice stuff. And if you're competitive, there is a leaderboard, which I'm not on because I don't solve the puzzles in less than a minute like a lot of people do. But I usually use this as an excuse each year to learn a new programming language. So each year I try to take on something new for myself, something I didn't do before. So in 2015, the first year that I did this, I used that as an excuse to learn Clojure. That's a Lisp language that runs on the Java virtual machine. It's a really great language. It's very thoughtfully designed. It stretched my mind out when I first tried to learn it to try and, you know, I was working in JavaScript and imperative, like functional programming was pretty new to me. But I really appreciated its consistency and how well thought out it was, how things just worked as I expected and changed my view of software. In 2016, I don't know what I did. Apparently I didn't celebrate Christmas because I don't have any records for doing the Advent of Code this year. But in 2017, I used it as an excuse to learn Elixir, which is a programming language that runs on the Erlang virtual machine. This is an actor-based language, very good at concurrency, very good at parallel processing, another functional language. And it has a syntax that's sort of loosely inspired by Ruby is one, you know, one major influence of its authors. A good, clean language that's really good at, you know, kind of like multi-user online and real-time applications. That's the kind of stuff I was working on. So great excuse to learn that. 2018, there is a programming language called Nim, which is, it just had some really nice features that I liked and I wanted to try out. It's not so much a functional language, but it has some really cool patterns of code organization and a nice type system to it. It was just a cool expressive compiled language. It does a trick of kind of compiling itself to C, and then anything you have a C compiler for, you can run Nim on. And also has JavaScript backend to it, which I was interested in at the time. 2019, I wanted to try and learn Racket, which is another Lisp. And Racket's big feature was being able to create new languages pretty easily. It has a structure of being able to turn, you know, code into like Racket Lisp data structures, and then from those into a working program. And there's this nice system of translators that do it. There are some great resources I can recommend if anybody's interested in learning about that, teaching you how to create a little language in Racket. So that was kind of the precursor to the advent of code in 2020. And I was thinking about, you know, what I wanted to do. This was a point where I remember that there was, you know, something that I had been like working on, you know, a little bit earlier in the year. And this was the language that I'm going to talk about today. I'll pause this for a little bit and show you all the origins of this, a little project that I was working on quite some time ago. This was, and Justin, you'll note, this is actually something I was working on when very early on when I joined InVision. I was like, oh, I didn't know you guys did this too. But this is like a little sort of collab whiteboarding thing that I was working on at the time. So we have these spaces here, and I had to load in all these little, you know, graphics and stuff you can draw, and you can say, hi. This supports multiple users and cursors and everything. Let's see, this is where I had a bunch of jokes going on between me and my siblings. Yeah, I don't know what we were talking about. Let's see. Oh, just got to chalk up another tally right there. So this was just sort of a fun little thing that we were all working on at the time. I had features like being able to type a status update. I don't know if you could see it on your cursors, but the root of this was this little thing. I had this idea that maybe you could put like a little terminal or a little scripting thing inside of this place, and you could have widgets and you could have, you know, more complex things. One of which, let's hope this still works, was kind of a little chat box widget here where you can say, I place just little chat boxes around on the canvas, and if you want to do other ones, you can do that too. So this was really just me playing around with this sort of real-time multiplayer stuff written in Elixir naturally, and I wanted to see how I could extend this with like a programming language in it. So some of my goals were I wanted something that could run in JavaScript, something that could be, you know, kind of sandboxed, because just sending somebody arbitrary JavaScript and running it in their browser seemed like a recipe for a bad time. So this led me to starting to build a little language, and I wanted to learn how to kind of build my own. So to resume this, let's get back ahead here. I found out about this online book, which is another excellent resource that I can recommend to anybody who is interested in learning about programming languages. This is a book that takes you through, from start to finish, the construction of an interpreted programming language. It talks about all of the necessary background. It's very approachable. I found that it was not academic. It was very practical. You get hands-on and start building a programming language. There was tons and tons of good information in here about how to turn source code into data, how to build parsers and Elixir, how to, you know, structure things in memory, how to build scope resolution, binding, and how to implement data structures. It's just a really excellent book. This is where I started learning about building programming languages. And another great resource was a project called Make a Lisp, or MAL. This is an implementation of a simple Lisp language. It takes you through how to build these languages, like a very simple Lisp yourself in any of your languages of choice, really. It has implementations in, I think, more than 80 different programming languages. So whether you're familiar with, you know, Java, TypeScript, Go, whatever your language of choice is, there is a sample project here that takes you through step-by-step of building a programming language in a programming language you're already familiar with. Which is just another really great resource. I in particular really liked to learn about parsers. And one of them that I started to learn that there is actually a really great landscape for this in JavaScript. And I'll get to that in a little bit. But these are both like great resources that I started reading about and learning about and getting into more and more. So in my research about programming languages, I learned about one that is called Red. This is a programming language that has been in development, you know, kind of for a while. It's based on another programming language called Rebel. I don't know if anybody has ever heard of this language. It's maybe what I'd call a bit niche. But among its proponents, it's known for being really succinct, really compact and powerful, very free form. It's designed by Carl Sassenrath, who is I believe, one of the principal engineers of the Amiga OS kernel. Very impressive guy. And this was a project of his for a long time. And I really liked it for its kind of succinctness. And I can show some of these things of like, the code examples of what exactly Rebel looks like. Some of these pages are, let's actually look at, there are some one-liners of this. So each of these black boxes here is a little snippet of Rebel code. And if there's anything interjecting, anybody wants to pause me and expand on anything, let me know. I know I'm going a little bit quick, but here's a little example of Rebel code, printing the source of a web page. Print, read, rebel.com. I can show this here. I have a little Rebel instance here. Here's what it looks like. Let's read. I'll allow it to connect. And there we go. We have the HTML of the Rebel website. There is support for, you'll notice something funny here is that this is not a string. This is a data type itself. Rebel has URLs as its own data type. If I type one in here, we see it's, yep, that parses just fine. And I can assign it to, I've lost my place there. My cursor got all lost. Let me try that again. If I type in a URL and I ask what the type it is, if I spell, if anybody's playing the bingo, there's one. There we go. It's a URL type. Another data type is email addresses. That parses just fine. And I can say type of is an email. Further, there is money, $10.01. I say price, $19.99, price, money. There are lots of these built-in data types in Rebel that make it pleasant as kind of a shell language, or something you'd actually want to script and use interactively. That was a big thing that I wanted for my project at the time, and I thought this was really kind of a neat way to do it. Yes, I'm typing email addresses and I'm typing dates is another one. I type 21 December 01. Yep, that parses fine. That is a date. Okay, so 21. And that's a, it's not just a string, it's a fully structured object. I can ask it for the day, and it will tell me it's the first day. Today, it's a month. And interestingly, you'll see that there are slashes as the access operator instead of the more common dot. I thought that was pretty neat as well. I'm going to see if I can also make this a little bit bigger. No, maybe I can't. I can't remember how. No, there we go. This should be a little bit easier to see. So I thought this was pretty interesting as well. This idea that sort of similar to like a URL, this was how you access things. I thought that was neat. This is just a really kind of quick look at this sort of stuff. Let's get a few other ones. There's a few of these where it's talking about a GUI. There is a package for this that actually fully supports like user interface programming, which is really neat. And I'll take a look at that as well. This is a variant of Rebel that is called Rebel View. So this is the same core language, but in here, this is a platform agnostic graphical interface toolkit. And there are a bunch of demos in here showing what kind of stuff is possible. And it's all using this, this nice, simple little language. So this is just a really, really fast look at it. If this is kind of a little bit interesting to anybody, I really encourage you to go like read and check this out too. But essentially, I really just thought that this was really cool. I thought it was neat that there was a little compact language. This entire executable is like less than or it's about a megabyte, maybe a megabyte and a half. And it was possible to do all of this with what was a really, really simple language that has no keywords. It doesn't have any reserved language features. You're free to use whatever terms, whatever words you want, and that it had this graphical thing behind it. This was really, really neat. So I'll go ahead and quit this for now. That's just a little bit of a quick look of some of the interesting things that initially drew me to this language, and I thought it was really pretty cool. So all of this is, though I mentioned the Red programming language, Red is, I guess you could sort of call it a spiritual successor. It is an implementation of a language that's very similar, but it has the capacity to be compiled. It's a new implementation. Its compiler, I think, is initially written in in Rebel, but it shares the same kind of concepts and the same things. Again, I just thought these languages were really, really cool, and this was the basis and the inspiration for designing kind of my own little variant of Rebel. There were some really cool ideas inside of it that I thought were fascinating, and there were some things that were a little bit odd and quirky, but I thought that this would be a cool challenge. And I thought that it might even be easier because it was relatively like syntax free, right? Like there isn't a function keyword, there's not an if keyword, there's not, you know, conditionals. It's all just this kind of thing. If I have, you know, A is 12 and B is 50, and I have either A is greater than B. In this case, I will. So what I'm saying here is either is a function, I have an expression here and something to do if the expression is true and something to do if the expression is false, and it'll print 50 naturally. So this is nice in that there's no, you know, curly braces and brackets. It's very, very free form. White space is not significant. You can put things on whatever lines you want. I really just like that kind of poetic nature of it. So again, I thought because there are sort of fewer rules to this language, it would be actually easier to implement. And I simply could not have been any further from the truth. So in contrast, of course, to something like, you know, just thinking about JavaScript. I'll pull up a couple of code examples. This is another website that I reference pretty frequently, is learnxinYminutes.com, quick little overviews of programming languages. When I was just looking at things, this was a great resource to just see what one looks like. But it comes to mind right now as an easy example of some JavaScript code. Looking at something in Rebel, a function call doesn't have any parentheses, it doesn't have any syntax, any semicolons, anything. Most other languages do. If I wanted to have a, you know, function call in JavaScript, I'm going to be using parentheses. I'm going to be wrapping my arguments in something. To assign things, you know, we have like var and let and const. It's, you know, you require, whereas an assignment in here is just A:50, and then yep, A is 50. That's assigning a word to a value. I thought it was very simple. There's no var, there's no let, there's no const, there's not anything like that. Really, this is a language of blocks, which are these sorts of things, you know, A, B, and C. And there are words. There are things like, you know, print, which of course missing its value argument, it's function. But if I just say missing its value argument, yeah, that's where I am. Yeah, can't quite remember that syntax. There's another one on the bingo card. But these essentially, the differences are just they're words and they are blocks. They are tokens that don't de facto have any meaning. And I think in fact I can be, and now if I say A, so what I've done here is just assign A to the print function, and now A is my print. That is a nice flexibility to have in this kind of thing. Like every part of the system is inspectable. I think if I do system, I can't remember what the invocations are here. Oh, and if anybody sees anything, this is my cat Pinto, who has just decided to come jump on my desk. Thanks, buddy. This is just all a bunch of really, really neat stuff that I liked about this language, and compared to something that has a lot more syntax, a lot more rules, a lot more restrictions on what you could do with it, I thought it would be easier. And like I said, turned out really not to be the case. So we can look at now some code, I think. I can show some of the things about how I started actually building this, but I will pause and ask if there's anything that anybody would like me to dive into a little bit more about anything I've said here, the languages, the background, or any such. If not, I'm just going to keep rolling.
Yeah, I don't see any questions yet. Go ahead.
Cool. All right. So let's take a look at, I was working on some of this stuff earlier. Okay, cool. This is still something that I am developing actively. It's been a fun project. All right, so let's start with kind of thinking about how I had to go about just turning source code text inside of a document into something that's structured. That's like the first challenge that I had to overcome in learning about all this stuff. I was going to do this in TypeScript because I know TypeScript very well. It is my natural language of choice. And in researching various libraries that are available to help you write parsers and write things that are, parts of a programming language, I came across this, which is my now parser library of choice, which is called nearly.js. This is an implementation of a parser algorithm that has a couple of interesting features, notably that it can be used kind of lazily. You can evaluate things piece by piece and see it parse as it goes, which is pretty interesting. It is used in a lot of different projects, from like domain-specific languages. It's pretty easy to write in. It's reasonably fast. There are faster ones. Other examples are there's a library called JSON, which is another one that I looked at. This is, if anybody's familiar with Bison, Bison is a parser generator that's, I think, goes back quite a ways. But it's a way to take like a formally defined series of how to break down a language, a grammar, and generate code that will be able to understand that language. This is that in JavaScript. And there is also a really interesting one called Ohm. And Ohm is, here we go, this is the page I wanted to. Ohm is another really great tool for if you have text that is structured and you need to understand something out of it. This is another really, really expressive library for doing that. So those are three that I looked at and that I have used. So if you have a problem of, I have some structured text and I want to get data out of it, I want to get structure out of it, these are libraries that I started to learn about that have been really useful to me in those sorts of things. So building up an understanding of completely unstructured text takes, naturally, kind of a bit of work. So let's look at one of these little examples that I have in here. I am going to, oh dear buddy, I have to let a cat out. Here you go, dude. Pardon the interruption, folks.
It's time for somebody to insert a commercial break. So anybody? No? No? Okay. All right, go ahead. Commercial break over.
I was trying to think of a kitty litter brand and I couldn't think of one.
Okay, and let me just see if I can make this into, oh, actually, there we go. No. There we go. Did that hide? There we go. So I have here a little, like a scratch file, and I have the result of running the code up here. You can see down here, I can inspect values and look at things that I need to. So this is a tool that I use to just kind of build and explore as I'm typing stuff out. So the first part of getting any of my code understood, and there's like a little bit of a source snippet right here, a really basic little program, the type that I started working with. That's really not complex in the least. It's just, a little chunk of a word and then a string here. And I had to start teaching a system how to understand this. The first part of this was to basically figure out how to break this apart into individual pieces. So I can see that there is a bit here that this is, a word. This could be a function call or what have you. It's a little bit of white space. And then I have a string here. So in determining what those basic pieces of your code are, basically what the words in your sentences are, is the job of something called a scanner or a lexer. There is a project in JavaScript that is called Moo, really fun name, that makes it easier to create these types of scanners, things that can just look over a string and start to extract the really basic structure from it. So this is something where you pretty much can just give it some sets of rules to look for things and how to find stuff and how to recognize it. In my really simple little language here, I have taught it how to recognize white space. This is just a regular expression for different types of white space. I've defined what comments look like in my little language, which is a semicolon till the end of the line. I've taught it what, square brackets, commas, parentheses, when to start looking for a string. I'll get into this in a bit. Dots, digits. This is the regular expression for, one single word, and how to match new lines. This is pretty much the basic little units of my language. This is the really fundamental building blocks and a little regular expression or bit of, a string that can recognize each individual part. So this is what constitutes the tokens of the language. These are the individual words that will start to make up the larger structure of the program. I've also taught it that it should not consider comments to be important. That's what this little bit of code is. And so if I give my source in here, this print hello world, and using this reset method, this resets the state of the lexer. It is a state machine on the inside and feeds in the source code. And now if I look at the array of outputs here, I can see, I'll just strike that out for now and look at the result. So we can see in here that there is this array of objects that it's been able to recognize to see that this first part is a word and it's print. The second part is white space. The third part is a quote followed by some characters in the string and then a close of the quote. This wasn't that difficult to actually get working. It's more the intricacies of all the different parts of the language that got tricky, but it can do other neat things, like if I put this inside of a block here, let's say I want to have this as a little block of code instead. In this case, we have a little bit of something that's different. We see it's a word, white space, and then here's our bracket token, and then the rest of our characters and string, and then the close bracket. So this was the first part that started to get me enthused, is I was really just working on this kind of tokenization of the language, how to get it to split into these really basic components. But this doesn't really give me much that's meaningful. Like if I were to parse dates or numbers, it could recognize that, that's what they are, but I'm not really going to do anything with them. It doesn't know how to do any expressions, doesn't know how to do math. This is just very, very dumb, but it's useful in that it gives me those basic building blocks. And this is just mapping over each type of one, seeing that you can see there's a word and then white space, word, white space, characters. So this gives me the basic building blocks of the language. And from here, I can start to teach the system some more advanced structures. That's where this the nearly library comes into play. This is where I start teaching the more advanced things. Not, oh no, yes, it is this. So I can show the whole how exactly this parser works in a little bit. But this is a sample of a little bit more of a more intricate code sample in the language I'm working on. I'll go ahead and start the code inspector. And so in here, I can see there is much more structure in this. This is using the same tokenizer behind the scenes that's taking each individual piece, breaking it apart, recognizing that this is one bit, this is another bit, this is another bit, this is one, here is a parentheses expression, here is a block, or rather that this is the start of a block, this is a word, the end of a block. So it's creating a linear sequence of these tokens, and then I am able to use nearly to create a parser that can interpret structure on top of these. So if I look at the output of this, these are my rules of my grammar, and I'll show that in a minute. But this actually has some nesting to it. This isn't just flat. This is showing the body of a program, and a block. And then we have, this is a type, these words followed by a colon. This is an assignment. So this is called a set word. So we have a set word, and we have numbers, and we have parenthetical expressions. We have blocks and strings, and we have dates as well. This is where dates start to be able to be understood. This took a lot of time to really get right, and I'll show the output of one of these big grammar files. So at the top is my lecture. This is me teaching what all of the tokens are in the language. There's a lot more here. It's much more intricate than the really basic version. And this took me a long time to figure out. Then there is a series of rules. This is where the more interesting part of describing a programming language actually comes into play. Here, essentially the way that these parsers work is they have a table of rules. A rule can be some type of symbol, what we call a non-terminal expression, such as sequence or number or string or date, or it can be something that is very concrete and specific. If I scroll a little bit further down, I'll start to see these things like specific white space characters. These are what we call terminals. These are the tokens that are produced by that Lexer program. So the algorithm inside of the nearly.js library is essentially something that looks at the sequence of tokens and attempts to match wherever it can a sequence of tokens to a series of rules that I've described, and this is what's called a grammar. And at the top, you can see that like it's not super crazy. Everything starts as a program body. A program body is a sequence of something. A sequence is defined a little bit further down as, an expression followed by a sequence, or maybe an expression, then a block, then a sequence, or an expression, then a block, or just an expression on its own. What is an expression? An expression can be a number, a literal, a tag, a string, any one of these different things. So this little syntax here is just showing us what the name of this rule is and what types of things it can possibly match to, or what it can produce. So all of these are the different types of things that can be an expression, and an expression can be used inside of a sequence, and a sequence becomes part of a program. That's the really basic top level block here. And if I switch back over to my my parser sample here and look at this, you can see up here that that's exactly what we're matching here is a program body and then blocks. And so these are each the names of the parts of the language. Each rule that matches is named here, and then it has some information about what the value of that part of the syntax is. So this is building up really the syntax tree, because these things aren't flat. This is a block, and these things can be nested together. There can be blocks inside of blocks arbitrarily deep. This is where we start to go from a linear sequence of these tokens of characters into trees, into like trees and expressions and all that kind of stuff. So I'll go back a little bit here. So there are a lot of things that I started to learn when I was doing this that were pretty humbling. Originally, I had operators were kind of their own thing, like plus and minus and greater than, less than. I had those as their kind of their own thing. They were not parsed like regular other tokens. That got kind of weird. That's where this binary operator bit. And this code is littered with, I just don't do this anymore. A lot of things have been commented out and changed. But this required rewriting, a couple of times. A lot of times I would go in and try to add something to the language, and I would just find that I couldn't really do it without breaking a lot of other rules. And that was part of the process of this, was just realizing that in how you break down a language, even something like if you wanted to write a parser for JavaScript, say, you might make decisions about how you put you put those tokens together that isn't quite right. Like maybe something that in certain cases it could look like a string when it's not supposed to be a string, or it could look like, a keyword or, a conditional thing when it's not supposed to be. And those sorts of things really messed me up in the beginning and were the cause of a few different rewrites of this grammar under different assumptions. And after a while, I finally started to get it right, what actually is required. And there's, as you can see, there's a lot of rules in here. So I'll point out one of the, let's say, I'll point out one of the kind of the things that I learned about this when, why a lot of languages are designed in the way that they are, the stuff that I thought was superfluous in, in Rebel and in the language that I'm working with. You just say print hello world, that's a function call. In JavaScript, this would be there's also, if you were going to have a date type, you would say in Rebel, it would be, what date is 1 December 1. In JavaScript, of course, you could have is, var date, and then I can have, I think you can put a 1 and parse the date in there. So I realized that having something like this is nice to be able to do these dates and email addresses and money and stuff inside of it, but it makes the parser really complicated. It means that up front, I have to understand what a date is, and I have to understand what money is. I have to understand what email addresses are, and that made it really complicated to actually be able to work on this thing. It took a lot of time up front to get that kind of right. Whereas, in another language, you just have, it's a string, and now I appreciate the simplicity of this. It's the same thing, money. If I had maybe a new money data type where I have $19.99. In any other language, it would just be classes. This is one of the things that I realized, makes a parser of this type like a lot more complicated. And this is just, you get more mileage out of the same constructs of the language. This is just numbers and, a function call and a constructor. These are the same basic units. They are just applied slightly differently, whereas this is very specific. That was something that started to leap out to me as I was designing this. And so, you could see like again, just going back to this, how complex it is. There is an example in the, let's look at, actually, if I look at the editor here and I look at the ES5 example, so this is a grammar for all of JavaScript. This is in a different parsing algorithm, but it shows that there is this like a lot of complexity is around how particular like Unicode is handled and everything. But this is also a good example of how these kinds of things break down and how a parser actually looks at some of these texts. So here's like an example of this var x equals 3 up here. This is a great interactive explorer that shows you what each rule is producing at each step. And again, like another kind of great resource if you're at all interested in this kind of stuff. And I can see each production that has happened in turn as it goes through these rules. So here is a variable statement. It's showing me that all of this code highlighted in blue is a variable statement. And there's a list of variable declarations. We're getting down into, having an initializer. These are all the different things it tried to match, looking for, what different types of expressions it could be until it figures out, no, it's just a literal number. Here's a little bit more of a complex one. This is, I think if I also do, this is a pretty neat feature of this as well. Starting from nothing, this can step forwards bit by bit and just kind of show what it's trying and testing as it tries to figure out what the source code is. So each of these is just trying to parse this little function expression here and figures out, there's parentheses, but you can see everything that it is trying to match and failing, going through each rule in turn and trying to figure out where and how things actually match up in producing, meaningful information. This is just like a really cool demo here. So I also don't think I can see the hand raises. If there's anything that anybody, any questions or anything so far?
Anybody have questions? I don't think so.
No? Cool. I know this is like kind of a lot and I'm really just kind of firing through it, but this was, a lot of learning about this stuff. It was difficult to get to a point where I had, even these kinds of things working, but after getting this working to the point where, if I look at like the parser here, I had these structured things. I could tell what the actual pieces and parts of the language were, and this is where I started to think about, like what can I do with these things? I actually want to start getting some logic in and getting things working. So that's when I started working on kind of more of the kernel of this thing and building its like runtime implementation. And so the way that this language works is it's all an interpreted language. It's everything is written in TypeScript, as I mentioned, and I'll show a little demo of that. So if I look at this, this is my this is the language running right here. And I can say 5 plus 8. Yep, we get 13 there. I can assign variables to things. 5, 8, and I can do. Get 13. So this is just a really quick little sample, but this is the parser that was built up, the lexer, the language behind it. There is a lot of stuff going on behind the scenes here that even in just this little tiny example of performing a little addition, binding a variable to a value and evaluating it and looking it up, those are all things that had to be implemented. So there is if I have, a block of things, these can be 5 plus 8. That is, of course, just, a block of values. If I ask the type of it, it tells me it's a block. If I ask for the first thing inside of the block, it tells me it's 5. If I ask for the second thing inside of the block, that's what my error messages look like right now. It says it's a plus, and if I look at the third thing in the block, it's an 8. So those are just little bits of data. And, I can say type code block. That's a number. And I can say the type of the second item of the block. That's a word. There's nothing special about that plus. It is really just its own meaningless symbol. It's in the standard library and in the actual interpreter that learns what a plus means and what these data types are. But I could say I do. The block do is one of the functions that evaluates these things. I get 13. So this is a nice aspect of the language in that these things are all just data. There's nothing special about the code per se. You can read and change anything. It's very Lisp-like in that way, that there's no distinction between code and data. The interpreter figures out how to work with instructions inside of a block of data if they match a particular dialect. And that's kind of one of the really neat ideas from Rebel is this idea of dialecting, that you tend to create task-specific or domain-specific languages to accomplish what you want to accomplish. And it makes it straightforward to do so because you can redefine the words at any point that you need to. So let's see what I can talk about. So inside of here, I have a lot of these different parts of the runtime. Well, actually, I think we can start with This is just kind of the core of my little REPL class in here that I put together to be able to actually type things in and get them back. I'm trying to think of a good place to start. This is where like my preparation has definitely really run out. So if there is anything that anybody's even like curious about or I could like dive into, I definitely could do that. I'm just trying to think. Let's see the chat. Oh, about the runtime. That's a good question. So in my implementation, I really wanted something that was going to make it easy to kind of play with those constructs of the language itself. So changing what the functions are, changing how things work, changing the like rules of evaluation. So one of the things that I came up with was I wanted to make this very easy to kind of extend and change stuff. So inside of the kernel of this is essentially it's a loop, and it's very core. It is really just a loop. If I look at what the inside of this kernel class is what does the actual evaluation. This starts up the runtime. This gets everything, the standard library loaded. That's what I call the mezzanine. That's what Rebel calls it. I just thought it was cute. So this loads up the basic standard library file, puts it into the runtime, and there's this eval function is what actually does the work of the language. So in here is the parser that I showed earlier. We feed strings into the parser. We get the results out of the parser. And then this evaluate function is sort of the heart of the language. Once I have those data structures that represent the code and everything, I give it to this function and it works through it as far as it can and returns a result. So since essentially all of these things are or must reduce in some way to an expression, my classic 5 plus 13, that's an expression. Going one bit at a time, I can kind of see actually if I start this and I actually see. There we go. If I start this this REPL in my debugger instead of my regular console here, should be able to do the same. Oh no, that's because that is here we go. There we go. I can stick breakpoints in here and see what actually happens when I attempt to do something. So if I just say 5 plus 8 and start with that. Here we've stopped inside of this like evaluate function. This is the really core loop of the language. And so this load bit here, I dive into this. At the most basic level, there is kind of a dialect of the language that just has a concept of what addition is and setting and retrieving variables and doing the basic tasks of a programming language. Since at its core, this doesn't really have any meaning. They're just sequences of tokens and words and operators, and there's no inherent meaning. You could give it to an interpreter which has no idea what to do with this, and it would just basically return it unchanged. There's nothing to do with it. It is already a sequence of data essentially. Diving into this is where I start to look at how to turn these things we see here is like this program body structure is familiar from earlier. This is the syntax tree of the program itself. I can look inside of here and see that it's made up of a block. There's my number, my plus, and my number here. So this is the little program that I'm attempting to step through and evaluate. So inside of here is what would be called a tree walk interpreter. Essentially, I have the tree of all the different things of the language, and one by one, I'm going to go through, visit each node of the tree, figure out what to do, and build up my computation as I go. So this bit of the code is really just trying to figure out how to interpret each piece of the tree in turn. And it's recursive mostly itself in parts where it comes across a block. Well, it's just going to kind of dive back into itself. It's going to dive back into itself and just try and recurse and figure out what to do. as it does in here. So here's another call into here. Well, it's not a string, it's not a null. Try to figure out what it is. Okay, this piece of it is a block. So we've gotten to the point where we're looking at the block. And now we're going to actually turn that into a data structure. This is a part that actually creates that block structure. And then I can step over that and then return that. So each one of the data types in here, if I look for make block in here, each one of those data types, dates and errors, files, functions, every single thing has its own related class in TypeScript. So yeah, in here, tuples, tags, parenthized expressions, pairs. There's a lot of these data types that come from Rebel. Yeah, here's the block. So each one of these data types are implemented as classes in here. Array values types of reference with respect to equality. What about hashes? That's a good question. So right now, the only type of equality that really exists is basically identity equality. Numbers and strings can be, compared, like the basic types, words and numbers and strings can be compared. I'm just gonna continue this and actually snooze the breakpoints here. So I can say that that will evaluate true naturally. There is a syntax for the words as, so if I say, I assign, if I just try to call A here, it's going to say it doesn't know what it is. A has no value. But I can also say that I just want the literal word A by doing this syntax, and that tells me that is an A. The same thing with a B. That's just giving me the word. If I ask the type of that, I can say that that's a word type. So while just if I give the interpreter just kind of a word like this, it's going to try and look it up. It knows that it's supposed to look for something there in place of the word. But if I tell it to do a literal, it's just going to look for the word itself. And words are compared equally, but everything else, blocks will be equal as well. Oh, I guess I did implement. See, now this is me running up against forgetting what I actually did implement, and is what is just bugs in the language. So, okay, so I did get around to implementing this. That's cool. So blocks actually do compare like their contents with the default equality operator. As for hashes I have not implemented yet. That is a feature in plain Rebel, and I believe they're, that is going to be true because this is, under the hood is JavaScript. And so it has the same numeric aspects as JavaScript. So yeah, 1 is going to be equal to 1.0 floats. Floats, floating point operations are subject to the same kind of limitations as JavaScript. You'll get like little rounding errors and stuff. So yeah, it being JavaScript under the hood is going to be subject to those same basic rules. I guess that's something I should have just said in response to your question up front. Underneath all of this, it is all built on top of JavaScript. So it's building on top of JavaScript's runtime comparison and equality rules. Let's see, that's a good question though. That's the kind of thing that this made me have to start thinking a lot more about. And just looking and thinking like that question of what is equal to what is a really interesting one. Do you compare things structurally or just by where they are in memory or by their their literal values? That is something that I respect people that have taken the time to really think out, but it's fundamental. Cool. Well, if anybody saw, oh yeah, 1 over 0 versus, yeah, that I definitely, I'm not even sure what it would do at this point if I did 1 over 0. Hey, it tells me infinity. There you go. That's another JavaScript thing. Yeah, same thing. So there you go. This is giving you the direct hint that underneath it all, this is JavaScript. I did have a couple of other kind of cool demos. And again, if there's any other questions about like, I don't know, like this was kind of, I guess I can talk about a little bit of how I did the built-ins and everything. I wanted this to be like kind of extensible. So a lot of these are my kind of like really basic math functions are all implemented as these little native functions in JavaScript. So underneath, underneath all of this stuff, this language and everything, a lot of the basic pieces are implemented just as JavaScript. This is an example like the plus operator here. This implementation is when it's run inside of the evaluation loop, we have like the bindings that are available in the current scope and context. So that's like an explicit thing, like bindings. I had to create a class to actually deal with the bindings of each scope and to be able to look things up inside of it and perform the operation and return it in the right data type. Same thing with like, minus and multiplication and all the different mathematical operators are implemented here. This one is doing equality. So I guess there's another thing to touch on with the equality comparisons. This is the function that implements that. It can essentially does like type by type. It has some special rules for different types to see whether they compare, equal to each other, how to compare strings, how to compare various types of words, how to compare, nuns and nulls, how to compare logic. So all these different things are capable of comparing stuff to each other. And if it doesn't work, because there's a lot of comparisons I haven't implemented yet, just throws an error. There's a lot of stuff like that. It's very incomplete. But yeah, there's a lot of things built up from that that are used for the basic comparisons. But this is basically the way that I started to build up the standard library. Was here's like the string functions. Here are the functions for dealing with like lists, appending and inserting and getting a length and head and tails of things. So all these are just written in little snippets of JavaScript that work with that runtime representation of all the data. And then there's a bunch of different functions inside of here to perform, like I had this example. I think math should work. 0.0. Well, I am very used to the like the JavaScript way of doing this, which is, I think, kind of a cop-out. It just, by comparing anything to infinity, multiplying or dividing anything by infinity, you get further infinity. If I do that in here, I'm going to get, well, that's not a number. See, here's another one on the bingo card. I forget basic JavaScript stuff. I like and would love to implement something that is actually able to represent these as like rationals. Like that is something I really liked from Clojure, the idea that if I did like kind of a division, it would give me a rational, and then a rational was like a data type in the language, so I could compare, something over something up until the point that I actually had to produce an answer for it or produce a computation for it, and then it would give me, an error or a meaningful value. That's something that I wanted to explore, is having a data type for rationals. And I hope that answers the questions as well. This is kind of giving me, I'm returning to this project after a while, and plus 5. It's probably going to be this should absolutely be the same as JavaScript. Yeah, not a number. That's as expected. Right. I think I'm kind of touched on the stuff that I think I have natural inroads to. I've got like a couple of other demos, but yeah, I completely agree that JS math is nutty. And it's one of the things that kind of bug me, is that choosing to do this in JavaScript and TypeScript, that I don't have a real integer type. I don't have, a decimal type. I don't have, I don't have big ints. I don't have arbitrary precision, math or anything. Like there's actually a lot of stuff that I got used to from like Elixir is one good example, where its numeric system is arbitrarily sized. You can have, numbers that are big ints that are huge, that are capable to be operated on it at any limit of precision. which is great. And it's really nice that it's built directly into the language. The fact that these things are missing in JavaScript makes a lot of this stuff harder, and there's no real way to replace them. That's kind of what got me thinking about how would I do like this in WebAssembly instead, and I can have, you know, whatever, or I guess I could build in a very manual way, whatever types I needed to. There's a lot of stuff I did learn though, that those sorts of like those decisions and restrictions in like the language. I don't know, I pointed out the function example earlier about how, you know, of course, these types of things need to have a function call in JavaScript is parentheses, and you know, you have to have something to delimit what the arguments are. And I kind of learned that having more rules and restrictions on this stuff makes it easier to describe the language and interpret it and understand it. Can't remember where my scratch file went for this, but the idea that in this language that there is no delimiters for those sorts of things. You know, again, I'll go back to this. That just makes it really hard. If print isn't the function, then this means something totally different. If I were to just do a hello, that's meaningless. If I were to say, you know, do as a block, print hello, that prints hello. But if I do a hello, that gives me, you know, again, the same, like being able to have those sorts of parenthetical delimiters. Actually, you can tell very early on when you're looking at one of these things, like, I know this must be a function because it has parentheses right after it, you know, or I know that this has to be, you know, like switch is a keyword. I know that what is going to follow is an expression in parentheses and then, you know, a series of these statements. In this language, there is, you know, we have like we have conditionals, we have switch in case, and you know that these kinds of things are all. Well, I actually think that some of my tests here. These are a bunch of just little snippets and examples and that I came up with for this stuff. Let's see, where was my? Yeah, so here's like, you know, this is an example of what a case statement actually looks like. And this is my test suite that just tests the kernel. But in this case, like this word, I realized it's really hard to understand what this is in order to optimize it. Because until I actually get to this word in the interpreter and look at it, I don't know that it's the function that implements case. And I don't know that this is an operator. I don't know that this is, you know, what is inside of these things until you get to them. So it makes it difficult to actually optimize, and hence why I get this is like originally Rebel is a, you know, a totally interpreted language, but that was like a big takeaway, that being more, you know, like restrictive actually helps you in actually building and implementing these things. And I actually wish it had been simpler, but yeah, thanks for asking questions, by the way. I am just trying to think of what other kind of interesting stuff I can go over, or if you know, anybody has like other questions about just like resources or this process or anything. So there is no virtual machine other than just the JavaScript virtual machine. This is all just stuff in memory. There is no virtual machine at this point. I haven't gotten to the point of implementing it. This is a fully interpreted, like tree walking interpreter that's just in JavaScript. So it is just the JavaScript virtual machine. And let's see, I will check my my notes here as well and see if there's anything else that I wanted to touch on. Yeah, I guess like there's like I said, there's plenty of things that are like really okay. Oh, so the JavaScript constructs are what I did put parse data dialect. This is the bit that starts building up like those JavaScript constructs that represent each part of the language. So as I pointed out, like each of these, like things like, words and numbers, and path is another data type that represents, kind of like an access path into a data structure. Each of these has their own, essentially it's just a JavaScript object. It just returns, and this is a little bit of TypeScript indirection I had in here. But if I look at the string, it's just a class here that has an indicator of its type. This is the same field name for each one of these types. A quick little constructor and an accessor for the length and everything. So yes, the tree is transformed into these data structures which have runtime significance to the system. And when I was looking at that, really kind of the big implementation of all this stuff here is inside of this eval file. Let's scan, but let's look at okay. So these functions here, eval, that's what it is. Inside of this is kind of the core of the interpreter that decides what to do with each value as it encounters it. A lot of things will just act as kind of literals for themselves, like they will just get returned as is. This is that JavaScript class instance that represents each one of these types. So by the time we've got here, this will be a JavaScript class. Anything that's special, like blocks, it knows how to handle like scoping and context resolution for them. Let's see, coming across like anything that's parenthesized is like eagerly evaluated. So it will be like evaluated before other parts of an expression. So that dives in and evaluates it. Coming across, one of these words to look up that will perform a lookup operation, find the value of a variable in the context. So inside of here, there is like a transformation that just turns those tokens into class instances that represent each of the data types, and then they're inside of these blocks, which are the arrays that define the order of them. And then just step by step, this interpreter function goes through and looks at each thing and decides what to do with it. And I hope that answers the question too. This is really not super advanced. It is really, really basic. It is really slow and pretty dumb, but I thought it was just cool that it works. Cool. And really, I guess one of the things that was kind of funny to me is that when I talk about like peeling away the magic, like it's a big loop that does this over and over across an array of things, and sometimes it recurses. Like this function is really just a big switch statement inside of it. And these things are not really extremely intricate. This is just kind of the beating heart of a tree walking interpreter, is just looking at each bit, deciding what to do, and moving on. Function calls were a really fun one. That does have some intricacy to it, but yeah, this is like 90% of where the code time is spent is just somewhere as a descendant of this part of the loop, piece by piece. So anybody else have like other questions or anything curious about? Because I think that's kind of what I have like time to get into, or if anybody just kind of wants to talk about languages and stuff in general.
Anybody? All right.
No? Well, yeah, I think absent any like other questions or anything,
Armand, I pasted some of the resources, some of the links that you had mentioned.
Cool.
If I forgot any there, feel free to add.
Yeah, no, that's what I went over. There is oh, I can put in a couple of like GitHub repos as well. Just go over some of the stuff that I suggested. So nearly this is the parsing library that I'm using. Recommend, nice. It's been good to me. This. There we go. I knew I had it in the history somewhere. This is the Lexing library that I like to use, and I'll put in. I'll put in this as well. This is another good. Like I said, this is the building a Lisp in whatever language you find handy. 86 languages. That's what it was. These are all different implementations of this. You know, a walkthrough of how to build a simple programming language in a language you're already familiar in. This is a great way to learn. Cool. So yeah, if there's nothing else to dive into, that's cool. But I think that's what I've got for everybody. Thanks for letting me share.
Thanks, Armand.
Yeah. Yeah, I'll switch off the screen share.
All right. Well, thanks everybody for coming.
Yeah, thank you. Thank you again, Armand.
Yeah, I appreciate it. Thanks, everyone.
All right, we will have a meeting in January. We will put something out on the website when all that's finalized. So thanks for coming. And thanks again, Armand. And I'll have a good Christmas.